Hello everyone. Let me introduce you a presentation about Bernoulli's theorem. My name is Bimurzaev Askar and I'm instructor of fluid mechanics. This is outline of this presentation, objective and method. The objective of this experiment is to investigate the validity of the Bernoulli equation when it is applied to a steady flow of water through a tapered duct. In this experiment, the validity of Bernoulli's equation will be verified with the use of tapered duct Venturi system, connected with the manometers to measure the pressure head and the total head at known points along the flow. The following equipment is required to complete the demonstration of the Bernoulli's equation experiment. Hydraulic bench, Bernoulli's apparatus test equipment, stopwatch for timing the flow measurement. And let me show this video about experimental procedure of this experiment. The Bernoulli equation is an important relation in fluid mechanics since it expresses the relationship between the fluid pressure, velocity, and elevation. Since for an expressible fluid along the streamline, Bernoulli's theorem is based on four assumptions for fluid flow: frictionless, steady, incompressible, and along the same streamline. This dead section is an accurately machined clear acrylic circular duct of varying section. It is provided with a number of side hole pressure tapings, which are connected to the manometers housed in the rig. These tapings allow the measurement of static pressure head simultaneously at each of 6 sections. The test section incorporates 2 unions, one at either end, to facilitate reversal for convergent or divergent testing. A hypodermic probe is provided which may be positioned to read the total pressure head at any section of the duct. This total pressure head probe may be moved after slackering the gland nut. This nut should be retightened by hand. All 8 pressure tapings are connected to a bank of pressurized manometer tubes. Before starting the experiment, set up the Bernoulli equation apparatus. One on the hydraulic bench so that its base is horizontal. Ensure that the test section has the 14-degree tapered section converging in the direction of flow. If you need to reverse the test section, the total pressure head probe must be withdrawn before releasing the mounting couplings. Ensure that the rig outflow tube is positioned above the volumetric tank. Connect the rig inlet to the bench flow supply. Close the bench valve and the apparatus flow control valve and start the pump. Gradually open the bench valve to fill the test rig with water. In order to bleed air from pressure taping points and manometers, close both the bench valve, the rig valve, and open the air bleed screw. Now open the bench valve and allow it flow through the manometers to purge all air from them. Then tighten the air bleed screw and partially open the test rig flow control valve. Next, open the air bleed screw slightly to allow air to enter the top of the manometers. You may need to adjust both valves in order to achieve this. Retighten the screw when the manometer levels reach a convenient height. The maximum volume flow rate will be determined by the need to have the maximum H1 and minimum H5 manometer readings both on scale. Readings should be taken at 3 flow rates. Setting the flow rate. Take the first test of readings at the maximum flow rate possible with all manometers hidden on the base board. Then reduce the volume flow rate to give the H1-H5 head difference of about 15 mm. Finally, repeat the whole process for one further flow rate set to give the H1-H5 difference approximately halfway between that obtained in the above two tests. Take readings of the H1 to H6 manometers when the levels have. Ensure that the total pressure probe is retracted from the test section. You should carry out a timed volume collection using the volumetric tank in order to determine the volumetric flow rate. This is achieved by closing the ball valve and measuring with a stopwatch the time taken to accumulate a known volume of fluid in the tank, which is read from the right side glass. You should collect fluid air for at least 1 minute to minimize timing errors. Measure the total pressure head distribution by traversing the total pressure probe along the length of the test section, points A to F. The datum line is the side hole pressure taping R associated with the manometer H1. Finally, you may reverse the test section in order to see the effects of a more rapid diversion section. Ensure that the total pressure probe is fully withdrawn from the test section, but not pull it out of its guide in the downstream coupling. Unscrew the two couplings, remove the test section and reverse it. Then reassemble it, retighten the coupling. Repeat the set of readings as before. Be sure to clean up your station and any water that may have spilled. Following the lab manual, complete the results table and put together your lab report. Okay, thank you for watching this experimental procedure, and you have to perform this experiment and make calculations, and for this applying using this calculation to making some graphs. And finally, this is literature. Do you have any questions? Please ask. Thank you very much.